Hello everyone. Today we are going to talk about measurement systems analysis. Measurement systems analysis has to be performed at the beginning of measure phase and also during control phase of the projects. Measurement systems analysis helps us in understanding how much of the variation that we observe in the process comes from the measurement systems itself, and it also helps us in determining if this is well within acceptable limits or not. A measurement system contains two key critical parts, which are accuracy and precision, which have to be validated and ensured to be within acceptable limits during the MSA. Key steps involved in performing MSA start with checkup of resolution, accuracy, linearity, stability, and eventually precision, which can be done through a gauge R&R study. Resolution of the gauge should be able to divide tolerance into at least 10 parts. And if this is not happening, then the equipment needs to be replaced. Accuracy of the measurement system has three key components, which are linearity, bias, and stability. Bias is the difference between observed average measurement and the master or the standard, whereas stability is the variation that is obtained when the same person measures the same part equipment over an extended period of time. Linearity is the variation in the bias, which shows how accurate are the measurements over the expected range of measurements. This indicates whether the gauge has the same accuracy across all reference values or not. This is generally what is ensured and checked during calibration of various equipment. Possible causes of poor accuracy include error in the master or standard, worn gauge, gauge which is made incorrectly, gauge measuring wrong characteristic, gauge not properly calibrated, or gauge which is used incorrectly by operator. Similarly, causes of poor stability include calibration done not frequent enough or calibration done too frequently. Now we look into precision part of the measurement system, which has two components, which are repeatability and reproducibility. Repeatability is the variation when one person repeatedly measures the same unit with the same measuring equipment. This is also known as equipment variation. Reproducibility is the variation between means when two or more people measure the same unit with the same measuring equipment, and this is also known as appraiser variation. There are three types of gauge R&R studies that can be performed. Gauge R&R study, the cross type, is used when we have a minimum of 5 parts to be measured twice by two operators. Gauge R&R study, nested type, is used when we have to perform a destructive test and each part is measured once by only one operator. Attribute R&R study is used when we have attribute data type rather than a continuous data, and inspection involves classifying units as either good or bad. Once gauge R&R study has been performed, it's also important to understand how to interpret the results. For this, we will focus only on percent contribution ratio of variances column of the table. If this contribution is above 8%, then we need to replace the equipment before proceeding with any kinds of measurement. But if this percent contribution is within 2 to 8%, then we can proceed with the measurement. However, it would still be good to replace the equipment. But if this percent contribution is less than 2%, then this is good enough and we can comfortably proceed with the measurements. I hope you liked the lecture. Thanks for listening and goodbye.